The work of Nobel Prize has transformed our understanding of the world. While approaching the Nobel Prize winners in chemistry, we not only learn their achievements, but also the spirit of honesty, tenacity, innovation, and forging ahead.
Hi everyone, welcome to today's class, the Nobel Prize winner in chemistry. 同学们大家好，欢迎走进今天的课堂，走进诺贝尔化学奖。Today I will introduce you a scientist whose name is Linus. He is a pioneer in quantum chemistry and structural biology. Do you remember that structure of methane that you learned in your chemistry class? Traditionally, it's believed that atoms have unpaired electrons in the outer layer before they are combined. If the spin of these unpaired electrons are inversely parallel, they can form pairs of electrons and form covalent bonds between atoms. When one electron pairs with another, it can no longer pair with the third electron. But this theory cannot explain the tetrahedral structure of methane. To explain the hydrohedral structure of methane and to illustrate the equivalence of the four bonds of the carbon atoms, Pauling put forward the theory of hybrid orbitals. According to Pauling, when carbon atoms bond with four hydrogen atoms around them, the orbital used is not the original s orbital or p orbital, but the hybrid orbital formed by the mixture and the superposition of the two s and t orbitals. Hybrid orbital theory explains the tetrahedral structure of methane well. Linus Pauling won the Nobel Prize in Chemistry in 1954. His prize motivation was his research into the nature of the chemical bond and its application to elucidate the structure of complex substances. Linus Pauling was born in Poland in the United States. His family came from the line of Prussian farmers, and his father worked as a pharmaceutical salesman and other things. After first studying at Oregon State University, Linus Pauling obtained his PhD from the California Institute of Technology, with which he maintained ties for the rest of his career. In the 1950s, Linus Pauling was involved in the anti-nuclear movement. It led to making him labeled a suspected communist, which resulted in his passport being revoked at times. The development of quantum mechanics had a great impact not only on the field of physics, but also on chemistry. During the 1930s, Linus Pauling was among the pioneers who used quantum mechanics to understand and design the chemical bonding. That is the way atoms join together to form molecules. Pauling worked in a broad range of areas within chemistry. For example, he worked on the structures of biologically important chemical compounds. In 1951, he published the structure of the alpha helix, which is an important basic component of many proteins. The atom bombs dropped in the Second World War were a turning point in Pauling's life. Together with other scientists, he spoke and wrote against the nuclear arms race, and he was a driving force in the Pugwash movement. It sought to be reduce the role of nuclear arms in the international politics. In 1959, Linus Pauling drafted the famous Hiroshima Appeal, the concluding document issued after the Fifth World Conference against atomic and hydrogen bombs. He was one of the prime movers who urged to the nuclear powers, the USA, the Soviet Union, and Great Britain to conclude a nuclear test ban treaty, which entered to force on 10th October 1963. Linus Pauling was awarded the Nobel Peace Prize in 1962. Therefore, he became the person who won 2 times Nobel Prize in different fields. Over the 7 decades of his scientific career, Pauling's research interests were amazingly wide-ranging. He made important discoveries in many different fields of chemistry, physical, structural, analytical, inorganic and organic chemistry, as well as biochemistry. He used theoretical physics, notably quantum theory and quantum mechanics, in his investigations of atomic and molecular structure and chemical bonding. In both theoretical and applied medicine, he made important discoveries in genetic disease, hematology, immunology, brain function, molecular evolution, nutritional therapy, diagnostic technology, and so on. Much of Pauling's life work combined the dedication and knowledge of the scientist with a deep commitment to the humanitarianism that supported his own ethical principles of the minimization of suffering. After Linus Pauling joined the Catholic faculty, he continues his intensive research on the formation of chemical bonds between atoms in molecules and crystals. To chart bond angles, distances, characteristics of particular atoms in relation to other atoms, he used X-ray diffraction, supplemented by electron diffraction, and an even newer technique that he has brought to US from Europe. Quantum mechanics enabled Pauling to explain the bonding phenomenon theoretically in a far more satisfactory way than before. Pauling's rules proved of great value in interpreting ionic structures, particularly the complex ones of many silicate minerals. He began to generalize the atomic arrangements in crystals with ionic bonds, in which negatively charged electrons orbiting around the positively charged nucleus are transferred from one atom to another. In 1939, Pauling brought together his work on these substances in his definite book, The Nature of Chemical Bond and the Structure of Molecules and Crystals, which became a classic and translated into many languages. A third edition appeared in 1960s and has remained in print to this day. The original handwritten manuscript was given by a former student of Pauling's to the Linus Pauling Institute of Science and Medicine and is now part of the Linus Pauling papers in the Valley Library at Oregon State University. Pauling's interest in molecular structure continued throughout his long career, and the theoretical calculations meant lots of happiness to him. Many of his discoveries and inventions were then expanded upon and utilized profitably industrially by others. And in later years, he was primarily involved in biomedical research. His curiosity often made him to identify complicated structures of many clay minerals, transition metals, and metallic compounds and other substances. In 1992, he was awarded one of his latest patents for a novel technique of fabricating superconductive material. While a visiting lecturer at Oxford University in 1948, Pauling had a sudden insight regarding the fundamental structure of proteins, an insight that had included him for more than a decade. He knew from the theoretical considerations that the chain could be bent, and he found that the polypeptide chain formed from the sequences of amino acids could coil into a particular helical structure, which he named the alpha helix. Subsequent X-ray diffraction studies have found that alpha helix is a major component of proteins and extensively controls their structure and function. A few years later, Watson and Crick proposed that the structure for DNA and the genetic substance of living things is a two-standard double helix, with one standard of helix complementary to the other. Pauline's proposals of helical structure and molecular complementariness underlying their theory. Confirmations in the knowledge of DNA structure immediately launched the new field of molecular genetics, which has revolutionized virtually all of biology. In the early 1930s, Pauline took over the teaching of freshman chemistry at Caltech. His modern theoretical approach to chemistry, charming lecturing style, and energetic showmanship made him a very popular professor. He also taught students about his current research, giving them insight into the professional chemist's work. He put his new approach to chemical education into General Chemistry, a textbook that greatly influenced the teaching of chemistry worldwide, by redirecting it from its traditional, purely empirical basis to the new chemical bonds approach. What did Pauline say in the Nobel lecture on December 11th in 1954? We may, I believe, anticipate that the chemist of future who is interested in the structure of proteins, nucleic acids, polysaccharides, and other complex substances with high molecular weights will come to rely upon a new structural chemistry, involving precise geometric relationship among the atoms in the molecules and the rigorous applications of new structural principles, and that greatly progress will be made through this technique in the attack of chemical methods on the problems of biology and medicine. So that's today's Nobel Prize winner, for whom we have known from our chemistry textbook. I hope you enjoy this lecture. Thank you.
大家好，莱纳斯·卡尔·鲍林是与20世纪同行的美国生物化学家，荣获1954年度诺贝尔化学奖和1962年度诺贝尔和平奖，是迄今为止世界上唯一一位2次独自获得诺贝尔奖的科学家。在鲍林近1个世纪的生命历程中，他参与和经历了20世纪科学史上许多重大的科学发现，首次全面描述化学键的本质，发现蛋白质的结构，揭示镰刀状细胞贫血症的病因，参与揭示 DNA 结构的研究，推进 X 射线结晶学、电子衍射学、量子力学、生物化学、分子精神病学、核物理学、麻醉学、免疫学、营养学等学科的发展。希望我们的本次课程能为大家学习和了解大师思想及创新历程打开一扇启迪智慧、滋养学识的窗口。好了，本次课到此结束，谢谢大家，再见。